Hello students, welcome to Saurabh Sir's classes. Today we are going to discuss about topology, and in this video first we will solve few numericals and then we will discuss about few further topics. So basic numerical on topology here says that let x be, we have a numerical where we have a set x which is equal to 1, 2, 3, 4 and 5. So this set has 5 elements in this set. Now we have been given that im, so this is a new symbol representing power set. This is power set known as im, that is im. So here we have this power set. 1 is given to be x comma empty set 5 comma 1 2 3, then we have 2 3 5, and the last element is 1 comma 5. So basically what is a power set? A power set is basically known as the collection of all the subsets of this set. Here we have a set x, so all the subsets of x, which means 5 1 2 3 4 5, then we have 1 2 1 3 1 4 and so on. So the collection of all the subsets is known as a power set. So here we have power set 1, then we have another power set 2 which is given to be, so the other power set is again x 5, then we have in this we have 1 2, then we have 1 comma 2, then we have 4 comma 5, then we have 1 2 4 5, and the last two elements are 1 comma 4 comma 5 and 2 4 and 5. So basically this is a set, and here we have two power sets of both of this set. Now we need to show that the second power set is topology on x, but the first is not a topology. Show im2 is a topology on x, but im1 is not. So how do we show whether a power set is a topology of the original set or not? For this we have a basic criteria. So for each a comma b are the elements. We can see here we have many elements in both the power sets. So a and b are few elements, and this if belongs to the power set, any power set, let either 1 or 2. If a and b belongs to the power set, then we must have a union b is belonging to the power set either 1 or 2, as well as a intersection b also belongs to that power set. If both these conditions, we have two conditions, that a union b belongs to the power set as well as a intersection b belongs to the power set, if both these conditions are satisfied, then we can say that the power set is a topology on the original set. So let us find, and starting with the power set 2, because here you can see we have been given that power is topology on x, but power set 1, that is im1, is not a topology. So we will begin with power set 2, that is im2. So here we have, so in im2 you can check, here we have im2, we have x empty set 1 2 1 2 and so on. So first let us check whether a union b belongs to that set or not. So for each element we will check whether the union with any other set belongs to this set or not. So here let me just clear this. Yeah, so here we will check with the beginning. Here we have x and 5. So the union of x and 5 will be x only, which itself belongs to this set. Then we have x with 1. So as you can see, we have x here. You can check, we have 1 2 3 4 and 5. So each one of this union with x will give us x only, because each one of this element is coming out of x only. So union with x will give us x, and x belongs to this set. So here we have got the union. Anything union with 5 will be itself only, and so it will obviously belong to that set only. So now moving on to the next, we have 1. So 1 and 2, union of 1 and 2 is 1 2. We can check, here we have 1 2. Then union of 1 with 1 2, we have 1 2 only, which also belongs. Then we have union of 1 with 4 5. So union of 1 with 4 5 is 1 4 5. So you can check here, we have 1 4 5 also. And then we have union of 1 with 1 2 4 5. So union of 1 with 1 2 4 5 will give 1 2 4 5 only, and that is obviously in this set. And so on, we will check that each one of the element is getting its union in the set only. So this A union B belonging to im2 is satisfied. And now we will check A intersection B. So for A intersection B, you can check that anything intersecting with X, any element intersecting with X will give us that element only, which is obviously belonging to this set. And similarly, anything intersecting with phi, so this will give us only phi, which is obviously belonging to this set. So we will ignore these two. Now we will move on to 1. So you can check, we have 1 with intersection 2, which gives us phi, which belongs to this set. Then we have intersection of 1 with 1 2. So intersection of 1 and 1 2 is 1, which is belonging here. Now let us directly go to intersection of 1 with 1 4 5. So this gives us obviously 1, which is again belonging. Then we can check intersection of 1 with 2 4 5, which gives us 5, which belongs to the element, which belongs to this set. So basically each one of the A and B, any element considering A and B, and intersection of both will also belong to this im2. So by this both the criteria, we can say that im2 is a topology on X. Now it was said to show that im2 is not a topology, so we can prove that very easily just by considering these two elements. First element, here we have third element as 1 2 3, then we have 2 3 5. So if you check the union or intersection, we can prove this very easily. So let us check union first. Here we have 1 2 3, union we have 2 3 5. So this union should also belong to im1. So let's check whether it is belonging or not. So the union of this will give us 1 2 3 and 5. So this should belong to 1. Now let's check whether we have element like 1 2 3 and 5. So you can check over here, we have no element as 1 2 3 and 5. So this is not belonging, therefore A union B is not belonging in im1. So first criteria is not satisfied. So by this only we can say that this is not a topology. But for reconfirmation, let us check the intersection also. And the intersection we can check in both this same element only. So here we have 1 2 3 intersection 2 3 5. This should belong to im1. So let's check what is the intersection here. The intersection here you can check is only 2 3. So this element should also belong to im1. Now let's check we have 2 3 or not. So in this whole set you can check we do not have 2 3 as an element. So A intersection B is also not satisfied. A intersection B is also not belonging to im1. Hence both these criteria are not followed. Therefore we can say that im1, here we have im2 is a topology, and here we have im1 is not a topology on X. So this is what we needed. So our question is proof. So hence proof. So I will like to end this video here. You will find some more topics and discussed and some more numericals solved on topology in our further videos.